Hello, everybody. With all this talk about astromining, especially some of my own talk about it, I thought it would be really cool to talk about where these minerals are even coming from. I know some of the commentary surrounding this space mining venture has been a little misinformed. Some people are wondering what kind of minerals we'll find aside from gold and platinum. And I remember a clip on The Daily Show where they talked about, will there be diamonds or space diamonds on asteroids? The answer is no. Diamonds, of course, are formed by coal that's been pressurized for millions of years, coal formerly trees. So unless those asteroids had trees growing on them and are so massive that they can exert the amount of pressure required to form diamonds, no, we're not going to be finding any diamonds. Everything we can find on asteroids can be seen pretty easily by looking at a periodic table. So a lot of great metals on there: gold, platinum, iron. Although it would be silly to go up there just for iron. But all those are the sorts of metals that are found on asteroids. And you might be wondering, where did these metals come from? That's a really good question. And why are they floating around on asteroids? The best way to answer that, though, is to figure out where these asteroids came from. To begin with, you may have noticed there are a lot of stars in the sky. And basically, those asteroids are the remnants of stars. In the beginning, so to speak, we only had about 4 elements, and it was mostly hydrogen and helium. And over time, these elements sort of compressed together to make stars. And for those that don't know it, a star is basically a nuclear fusion reactor, not to be mistaken with fission, which is what we use for nuclear power. But it's a nuclear fusion reactor where it's got sort of, for instance, our sun has a bunch of hydrogen atoms slamming into each other to create helium atoms. And the byproduct is a lovely light and loads of radiation that will kill you. So these heavier elements, if you look at the periodic table, and I'll just show you a quick picture of it right now.
Now, as I mentioned before, the only 2 elements within our own sun are hydrogen and helium, and it was initially mostly hydrogen, and over time the fusing of those hydrogen atoms became helium. The sun simply doesn't have enough gravitational pull to create the pressure required to fuse helium atoms, which would give us access to larger elements, or I should say heavier elements like carbon or oxygen. But when there is enough hydrogen and helium, they sort of form together in these larger O-class stars, which our sun is not. Our sun is an M-class. Now, this is a cross-section of an O-class star, which are the biggest stars out there, many, many times bigger than our sun. And basically, they're doing the fusion process through various layers. You can see that hydrogen fusion, that second layer, is basically what our sun is doing. But the helium fusion, where it gets hotter, and the further in you go, the hotter it gets, and the greater pressure is exerted on the atoms, which allows for fusion of these heavier elements, all the way up to iron. Now, if you remember from the periodic table, iron was about 26 on there. It was the Fe, ferrum, which is the Latin name for iron. And that's about as heavy as you can get inside a star through the normal fusion process. What happens for those heavier elements like gold and platinum? They're created when the sun, or the star I should say, runs out of fuel. And when it runs out of fuel, there's an immense amount of pressure, and they pop, they explode, they go supernova. And in that incredibly violent reaction, those atoms which could not fuse before are suddenly put into a state of much higher pressure and heat, and suddenly you've got heavier elements like gold and platinum scattering out of the remains of this supernova explosions, and the force of the explosion sends it scattering throughout the universe.
So those supernova explosions, which scatter these heavy elements across the universe, and within our own galaxy are responsible for the diversity of stuff we have here on the Earth. Life, human life, would not be possible without carbon or oxygen or all these elements which make us possible. A lot of people will charge science with being too cold and calculating and not accurately capturing the beauty found within our universe. I challenge anyone to describe something, describe the origins of everything we know on this planet to be more beautiful than the scientific finding that we are all and everything around us is made of stardust. I personally think that's incredibly wonderful, an incredibly beautiful finding, and it's an old one for sure. I'm not the first person to have brought it up, but it's one that's worth repeating, and it's one that's worth remembering. So I hope you enjoyed it. Thank you very much for watching, and as always, love science.